Hi guys, welcome back to In Case of Econ Struggles and welcome to another micro struggle. Today we are talking about the consumer problem. We're talking about indirect utility and the indirect utility function. What we're going to do today, we are going to review the utility maximization problem, specifically Marshallian demand. We are going to talk about indirect utility conceptually and graphically. Then we are going to just quickly review some optimization terminology. And finally, we are going to use that Marshallian demand to find indirect utility and talk about what it means. Timestamps are below if you would like to jump around, but let's go ahead and get into it with that review of the utility maximization problem and Marshallian demand. So if I have this utility function, which we've seen before, we have the utility of x1 and x2 are the two goods, and that utility function is equal to x1 to the 1/2 times x2 to the 1/2. From before, we know we have a shortcut where we can find the Marshallian demand easily using the exponents on each good, and it's just the ratio of that particular exponent with respect to the sum. So the Marshallian demand for good 1 is 1/2 over 1/2 plus 1/2, which is just 1/2, times total wealth over the price of good 1, and similarly for the Marshallian demand of good 2 or x2 star. So that is our bundle. Now let's take a second and think about what it means. So what it means is that we have this nice graph, and what we have done is we have found the maximum level of utility we can make given a certain budget and prices. Now the prices and the wealth go into this budget constraint, and we try to find the maximum indifference curve that we can hit with those parameters. Now that maximum indifference curve we know is going to be tangent at our Marshallian demand, but a question that we haven't answered when we solve this problem is what level of utility have we actually hit? So we know that we can score a bundle based on the level of utility we get, but we haven't yet answered the question, okay, what is that number? What is that utility that we get when we solve this optimization problem? And that is what we are turning to now with the indirect utility function. So the problem is, okay, I know Marshallian demand, but not the utility level. Okay, well, if I have the Marshallian demand, I can plug that back into the utility function and get the overall utility that I get when I solve this optimization problem. And that concept is what we call indirect utility because it is measuring utility using the Marshallian demand, but not explicitly. So if I have this Marshallian demand, which we just saw, and I have this utility function, all I am going to do is I'm going to take this Marshallian demand for good 1 and plug it in here. And I'm going to take this Marshallian demand for good 2 and plug it in here. And all that is going to be is that is going to be the square root of 1/2 times W over P1 times the square root of 1/2 times W over P2. I'm not going to simplify this too much. I'm just going to keep it as is. So this is 1/4 times W squared times 1 over P1, P2. You can separate it more if you would like and simplify, but that's where I'm going to leave it for now. Just to make sure this is super clear, let us revisit some terminology for optimization with the utility maximization problem. So I have this utility function, that is what we call our objective function. This budget constraint is what we call a constraint. And this Marshallian demand is what we call the optimum or the optimal bundle. So the definition for indirect utility is the value of the utility function or the objective function evaluated at the optimum, which is Marshallian demand, and that optimum, that Marshallian demand, will take the constraint or the budget constraint into account. So that is all we are doing with indirect utility functions. I want to make sure this is clear because later we are going to move on to something called value functions, which is going to be more general than utility. So having this definition of indirect utility in mind can be super helpful later. So why are we doing this? Why are we going through the trouble of thinking about indirect utility? Well, if I ask you the question, okay, how does your utility change if the price of good 1 goes up and you don't have indirect utility? Well, now you've got to go back, replace P1 with a higher P1. You've got to think about how your Marshallian demand changes. And then you've got to think about how that change in Marshallian demand affects your utility. So what you're doing is a total derivative of the utility function. You're saying, well, my utility function with respect to P1, well, how does U1 change with respect to X1 times how does X1 star change with respect to P1? Well, you also have X2, your Marshallian demand for good 2 will change. So you've got to add how your utility changes with respect to x2 star, and then times how x2 star changes with respect to P1. And then you've got to think about how your utility function changes with respect to wealth, because your wealth changes when you change P1. So now this is a whole mess of a total derivative. But if you do have indirect utility function, well, you can just say, okay, dv dP1. And we have P1 directly in this indirect utility function. So it's just a simple derivative and you're done, which makes it much easier than doing this total derivative mess. Hopefully this made indirect utility functions make a little more sense. If it did, make sure to like and subscribe, and we will see you next time for another case of Econ struggles.